Hey guys, it's Darcy again. So I just went and had a ham sandwich, ham baguette, with some pretty good ham I got from the market, some smoked cheddar cheese, mayonnaise, bit of mustard, like American mustard, and some I think they're like Black Russian tomatoes. Would recommend. But anyway, I can tell you more about my food tomorrow. So we're knee deep in reconstructing or constructing like a computationally designed Matthias Pliessnig structure. So in this tutorial, again, I'm trying to keep it on the lean side of things. We're going to go through and start to edit our larger rib structures to create our strip geometry. So let's jump in. So yeah, I left you here, and I'm just going to hide this interior geometry because you don't really need it at the time for the time being. That one as well. So what I want to do is, well, I need this one actually. What we need to do is generate a whole bunch of rectangles, really, around each of these curves. Now, how many rectangles are we going to generate? Could be 2, could be 12, but as long as each one has the same amount of rectangles, we'll be golden. Now, there's a little problem that we're going to encounter, or we might encounter, and I'll illustrate it now with a quick example. Okay, imagine this is one of those rib curves unrolled, and this is another one. So the difference in size of them is going to be, they're going to be pretty similar, right? But there's going to be a difference. And if I try and, if this is our strip geometry, and I go copy 1, 2, 3, 4. So let's say it holds 4. With a little bit of wiggle room, we'll find that this one holds, well, 7. Is it 7? Oh, yeah, we'll call it 7-ish. So it holds more, which is fine. But if these ribs are to be, if it's to be a continuous flow from here to the end, if we start with, if we say we're going to do 7 ribs over the whole structure, well, we'll find out pretty soon that 7 strips over the whole structure. We'll find out that 7 strips won't fit across this small bit of timber rib. So we'll have to work something out. So what we'll have to do is we'll have to choose a number of strips that goes, like the number of strips that goes across our smallest curve. So let's work that out now. So what I'm going to do is take our rib curves, and let's just measure the length of them all. Cool. And then let's find the smallest length. So we'll do that. I think we'll flatten all of you because there's a data structure behind it. List item. Cool. So, oh, wrong curves. There's our smallest one. It happens to be that one. That's fine. So now what we're going to do is I'm going to divide by length. So plug this in, and what we're going to say is, maybe we'll use a rectangular section that's maybe like 20 mil wide. We'll do that. And then while we're here, no, I won't do it now. And then I'm going to, so this component is divide length from paneling tools. It's not too bad because it gives you the option to round up as well. So we say, if we don't round up, it's what you do with the, like, leftover, like, so with the, is it the modulo? So, that length, curve length divided by 20 gives you, like, it might be like 20.1 curves. So you have the option, if you plug round up in, it'll go divide. It'll just create 22 points. You know what I mean? Or if you go round down, it'll create 21. Another way that illustrates this is one that I've written in C#. And we'll just plug the same distance in there. Sort of does it automatically, but it'll also tell you the length that it alters. So we wanted 20.00, and then it's gone and divided it. It gives us the same. It should give us the same, if not 102 or 101. Yep. And it said it's altered the length that we put in by like a very small amount, but that amount times 101 will give you like a leftover. So we'll do that. And while we're here, when I go back to top view, when I put our ribs in, I want to put a gap between them. Like a veranda. You ever seen like a veranda floor where it has a gap in it? So we're going to do that as well. And we're going to just do that by adding an addition sign in and maybe a gap of 6 mil. We'll just, whatever. Chuck that in there, and we'll use this one because I wrote it. Cool. So let's create our rib planes now. List length. So I'm going to create some perp planes now. Yep, perp planes, and then these are very big. There we go. And I think I need to add an extra one. 77. Oh no, that should be okay for now. So we're going to let's create a rectangle geometry now, just so I can show you guys what I'm talking about. Equal domain 20. So this is just a little component I wrote. Didn't really write it. Just takes an input and divides it by 2 and makes a negative and a positive over it. 10 and 10. Now, cool. We need these to face the other way. So let's deconstruct the plane, and then we'll construct another plane. We just need to alter it a little bit. Construct plane. We'll use the same origin. I think we'll use the same X, except our Z is going to become our Y. And I don't want to talk about plane geometry with you too much, but long story short, it works. There we go. Awesome. So we just need to do this. So, in order to apply this to the rest of our form, so in here we grab that smallest curve out to work out how many strip rectangles we're going to create. We're just going to divide all these curves by this one length, and then that's going to go and create rectangles over them all, like so, or the kind of squares actually, which is fine for now. We'll come and change it later on. And then we should just have to loft between them all. And you can see that that's kind of killed the computer a little bit. And this is just because our data structure has been done in a way that all these curves are on the same list, like that, so and so and so, see like that? So it's trying to create a surface around all of these curves, and because all these curves are on the same plane and they're intersecting, Grasshopper hasn't liked it too much, hence why it's taken 4.3 seconds to compute. What we need to do is we need to flip the order of our list. So in our rows become our columns, and our columns become our rows, essentially. So we just use flip matrix, and that should do most of the work. I'm just going to simplify my list as well, and let's see what happens. Oh, there you go. That seems to have done the trick. I think. Oh, we have something going on here though. I think the order of our curves might be a little whack. You see that? So yeah, I think we're trying to, one of our curves might be flipped weird or something. So I'll see if we can fix it quickly. First things first, I'm going to disable that. And let's come back. Nope. Cool. These are our curves. 1, 2, 3. Now I reckon that the order that I've referenced these in might be a bit weird. Let's have a look. Let's have a look.
Let's have a look. Let's have a look.
Okay guys, I'm pretty sure I know what I've done. I needed to not connect the curves that I'd sorted previously. So what's happened is the order's changed. So if I come back to here, let's turn on our really bad looking loft. And if I just do this, it's fixed it right up. There we go. So what happened was when I was sorting all our curves to find the smallest one to take the number measurement of, I sorted the rest of the curves and hooked that up into the parameters. Sorry, per flat frames, but I should have connected the unsorted curves, which is why I was getting a weird result. But there we go. And I've shown that my thing works on some different kinds of curves, but not all. But we'll talk about that in later subsequent videos. Oh, there we go. Beautiful.